Hello, in this video I'll be explaining how to both simplify and solve simple quadratic equations. A quadratic equation is indicated by its highest degree on a variable being 2. What this means is that the highest index or number in the superscript of a variable is 2. They take the general form of ax squared plus bx plus c, where a, b and c are constants. A quadratic equation can be simplified in two different ways. It can either be simplified as a perfect square, which is the general form of x plus a squared, or can be factorized in the general form of x plus a multiplied by x plus b. To manipulate a quadratic into one of these forms, the original equation must fit certain criteria. If we expand the perfect square of x plus a squared, we get the equation x squared plus 2ax plus a squared. This means that the second coefficient in the general form b is equal to 2 multiplied by some number represented as a, and the third coefficient in the general form c is equal to that same number a squared. For example, in the equation x squared plus 6x plus 9, 6 is 2 multiplied by 3, and 9 is 3 squared. This means that this equation fits our criteria for a quadratic that can be simplified into a perfect square. To put it into a perfect square form, we can solve for a as 2 multiplied by a would be equal to 6, or a squared would equal 9. When solved, this value of a is 3 for this equation. This means the simplified form of x squared plus 6x plus 9 is x plus 3 squared. This can be checked by expanding the perfect square form to backtrack and achieve x squared plus 6x plus 9. Once the quadratic equation has been simplified into this, solving for x becomes simple. As x is found when y is equal to 0, to solve the equation we make it equal to 0. The square root can be cancelled out as the square root of 0 is still 0, and 3 can be subtracted from both sides, resulting in x being equal to negative 3. Negative 3 can be placed back into the equation to check that is correct. To simplify a quadratic equation into its factorized form, we can begin by expanding the general equation of this form to achieve x squared plus ax plus bx plus ab. This means that the second coefficient in the general form, b, is equal to two numbers added together, and the third coefficient in the general form, c, is equal to these same two numbers multiplied together. For example, in the equation x squared plus 9x plus 20, 9 can be equal to 4 plus 5, whilst 20 can be equal to 4 multiplied by 5. This means that this equation fits the criteria to be factorized. Once both numbers are found, it does not matter which is a or which is b. Therefore, the factorized version can be either x plus 4 multiplied by x plus 5, or x plus 5 multiplied by x plus 4. This can be checked through expansion, and the original equation can be extrapolated. Factorization into this form can also be solved easily. Like solving for the perfect square previously, we let the factorized equation equal to 0, then both sides can be divided by either group in brackets. When this is done, one of the term remains and can be simply solved. In this sample, if both sides are divided by x plus 4, then x plus 5 equals 0 remains. Both sides can subtract 5 to achieve x equals to negative 5. This can be done with the other group to find x equals to negative 4. These can then be checked by placing either x as negative 4 or x as negative 5 into the equation to check that it is equal to 0. Thank you for watching. If you enjoyed this content and wish to see more content like this, please subscribe. This video was created by Simply Explained.